Hey everybody, it's Mr. Ray here with our next lesson in grade 11 University Math. We're working in the trigonometry unit, and today we're going to look at some trigonometry problems in 3 dimensions. So these can be a little more complicated than maybe the questions you looked at in grade 10. The concept of 3 dimensions is always a little more difficult than 2-dimensional word problems, but you're going to be using the same tools that you've used in grade 10, and that will be basically Pythagorean theorem, the trig ratios, sine law, and cosine law. So you'll be using any or all of those in a particular question. And it depends on, you can't just say before you read the question which tool you're going to use. You have to look at the question. And you have to interpret which tool will help me get the information I'm looking for. Now, with these word problems, there's no pictures in the original lesson document. In many cases, you will be given a diagram of the situation, but in some cases, you're expected to be able to draw it. So for all 3 of these, 3 examples that we're going to look at today. A couple of them are pretty complex, and you need to use your skills to convert the information on the description into triangles and what information is available. And the better job you do at that, the easier it's going to be to do the actual calculation part. Okay, so our first word problem example, radio antenna lies due south of Sam's house. Sam walks to Alan's house, a distance of 1,200 meters, 50 degrees east of north. From Elena's house, the antenna appears due west with an angle of elevation of 12 degrees. Determine the height of the antenna to the nearest meter. Well, when you first read that, there's so much information. It's very complicated, but we're basically going to start with the first part here, radio antenna lies due north of Sam's house. So I know I'm going to be drawing at least 2 triangles in every one of these questions. So I'm going to start with kind of looking from the towards the ground from the sky. So I'm looking at I've got Sam's house. So I'm going to start with Sam's house here, and the antenna is due north, so I'm going to draw it straight above. Actually, I'm going to move that down a little bit, give myself some more room. So Sam's house, of course, I'm going to label that S, and that is due north, even though it looks a little angled. I'm doing this kind of angle for the 3-dimensional purpose. And this is where the base of the antenna is. And then the antenna will be going straight up from there. So I can do that here. So I'm going to label this C for no apparent reason, but I'm going to call that A. So that's the top of the antenna. Okay. So this is like due north. I'm not going to write it on there, but due north. And then, so Sam walks to Helena's house, a distance of 1,200 meters, 50 degrees east of north. Okay, so what does that mean? So Sam's walking from his house, and it's east of north. So that's north. We already know that. So if Sam walks directly north, he's walking towards the antenna, but 50 degrees east of north, there'll basically be like a 50-degree angle here. And that will go towards Elena's house, which will maybe put over here, call that E for Elena. And there's the walk. And that distance we were told was 1,200 meters. So of course we're going to put that there. Now if we kind of complete this triangle here, which is on the ground, so I'm drawing a straight line from the base of the antenna to Elena's house. And it says from Elena's house, the antenna appears to be due west. Okay, so this is going directly west, this is going directly north, so that makes this a 90-degree angle on the ground. Okay, and I think that's all we know about that. So let's keep going. From Elena's house, the antenna appears due west with an angle of elevation of 12 degrees. So now we kind of start completing our third dimension, which is looking up. So I've already drawn this antenna here, which is straight up in the air. So you have to kind of imagine that's the third dimension. So that's, if I was measuring the angle from the ground, that's 90 degrees. But when Elena looks at the top of the antenna, it's saying it looks like it's a 12-degree angle from where she lives. Okay, look at my 1250 angles there. And the question is asking what's the height of the antenna to the nearest meter. So we'll call it h, little h for height. So h is actually that AC side of that vertical triangle. That's the triangle that's like vertical from the ground. And this triangle here, CSE, that is on the ground. Okay, so half the work is getting that information into a chart. So if I'm looking at this information and I want to get h, well, I can see that h is on it's on this triangle ACE. What do I know about ACE? Well, it's a right triangle, which is good. That means I could use trig ratios. However, it doesn't have enough information that I could use trig ratios yet. All I know about this is that angle there, 12 degrees, which combined with that angle being 90 would give me that other angle at the top. Angle A would be 90 minus 12. So 78 degrees. I'm not going to put it in because we don't really need to use it. But basically all we know about that triangle ACE is all three angles. We don't know any side lengths. And in order to find one of the missing sides, I have to know at least one of the other sides, and I don't. Okay, and that brings us to my first major hint about some of these two triangle three-dimension problems. Okay, so usually what you're trying to find is it's not going to be available based on the triangle that it's in. We need that secondary piece of information, which we'll get from the first triangle. So the big hint is it's almost always going to be that side that's common with both triangles. So if I could actually figure out what CE is using CSE triangle, that's gonna get me CE, which then I can reuse in the vertical triangle ACE to get the height. Okay, so I'm now looking. So the first thing I want to do, and you got to do this step by step. So number your steps so I can see what you did first, what you did second, etc. And it's good for you to organize it that way anyways. So my first goal is to find the side CE. So put what you're trying to get, and if it's ambiguous, meaning which triangle am I going to use, I don't know, actually put the name of the triangle that you're going to use. So for us, we're going to use that flat horizontal triangle on the ground, triangles, I'll call it SCE. Could be any of those letters in any combination. And it's always a good idea, you don't have to do this, but it makes it clear sometimes. If I redraw just that triangle, sometimes it makes it more obvious what I'm going to do. So here's C, S, and E. Right angle there, 50 degrees here, and then this side was 1200 meters. Okay, I'm really just copying that one triangle over here. Okay, so now I can see, well, I've got a right triangle here too. I'm trying to find this side here. So I could call it X if I wanted to. I'll keep with just the CE side. Okay, so I'm trying to find that side there. Now, which ratio? Well, since this is a right triangle, I'm gonna try to use trig ratios. So if that's my reference angle, 50 degrees, that's going to be my opposite side, which I want to get, and I know the hypotenuse, so it's O and H. That tells me it's the sine ratio. So it's going to be sine. My reference angle is 50, and then the opposite side over the hypotenuse. So the opposite side is CE, and that's going to be over 1200. So the units are going to be in meters. So I can figure out that CE, and to be more accurate mathematically, I'll put my lines down the side. That tells me that's the magnitude or the length of CE. So the length of CE is equal to 1200 times sine 50. So that's equal to 919 meters rounded. Okay, so I'm going to go back. I'm going to put that information on my main diagram that I just got. And now when I revisit, I'm still trying to get H, but now I know one of the sides of that triangle ACE. So my second step will be to find H in triangle ACE. So again, I'm going to redraw that triangle just to... It helps to redraw these just because it takes it from 3-dimensional to 2 dimensions, and also takes away the extraneous information that you're not going to be needing. So here we've got C, A, and E. That's 12 degrees here. That's H I'm trying to find, and then the side we just got is 919 meters. Okay, so again, right triangle, I'm going to use trig ratios. Which one should I use? There's my reference angle. So I need to use opposite, and the only side I know is adjacent. So that's going to be a tan ratio. So the tan of the reference angle, 12, is equal to opposite over adjacent, so H over 919. So H equals 919 tan 12, which rounded is 195 meters. So therefore, and don't forget the word problem, word answer. And don't forget your units. I put my units there, but make sure you also put it in your word answer. And if you forget what you're being asked, you can just go back, look at the question, determine the height of antenna to the nearest meter, which we've already done. So therefore the height of the antenna is 195 meters. And we're done, okay? So again, half the battle is constructing the triangles, or the picture of the scenario, from the information given. Sometimes we get a little bit lucky. Sometimes they give us the sketch and the description, but don't count on it for every question. And then once you've got your triangle, focus in on what you're trying to get. And almost every time it's at least 2 steps. Why would they give us 2 triangles if you only needed 1? Ask yourself that question. So you usually need to work on the other triangle first, get the common side that both triangles share, and then use that new information to get the actual thing you're looking for, in this case the height. Okay, so our second word problem in 3D. This is a very typical question. It's basically a survey. Oh, let me read it. A surveyor is on one side of a river. On the other side is a cliff of unknown height that she wants to measure. The surveyor lays out a baseline AB of length 150, and that's obviously on the side of the river where the surveyor is. From point A, she selects point C at the base of the cliff and measures angle CAB to be 51 degrees. She selects point D at the top of the cliff directly above C, measures an angle of elevation of 32 degrees. and then she moves to point B and measures angle CBA is 62 degrees. So we're going to do our picture first. And usually a question like this, they would give you a diagram. So let me just do the scenario here. So you've got your river, both sides. Okay, and then you've got like a cliff over here. So there's the drop, and then at the top of the cliff. Okay, so this is the river. This is where the surveyor is, and we want to measure how tall the cliff is. So based on the information given, so from point A, so point A might be here, and she measures another point that's 150 meters along the river side. It's point B. So from there to there, it's 150 meters. Okay, so we've done that part. From point A, she selects a point C on the base of the cliff and measures CAB to be 50 degrees. So so she's standing there, and there's a point, call it C over here. So point C. So we're going to construct a triangle using these 3 points. And this is not to scale, so don't ever think about using a protractor on stuff like this. This is all going to be formula based. So from that point C, she gets a couple angles. She actually measures these 2 angles from the side. So CAB, and remember that's the way of measuring an angle if it's a little ambiguous. In this case, she could have just said angle A, but CAB is this angle here. That is 51 degrees. She selects a point D. Do we use everything we got? Okay, she selects a point D at the top of the cliff directly above C. So right there, that's D. So if I run a line, this is straight down the cliff. So that's probably what we want to measure. That's the height of the cliff. Measures an angle of elevation of 32 degrees. So that's from where she's standing right now. So from A looking up at D. So here's your 3-dimensional triangle now. Okay, so this is a vertical triangle, ACD, and ABC is a flat triangle. It's basically lying on top of the river, and this is vertical, pointing to the sky here. So the angle of elevation is this angle here. So what's the angle compared to where she is on the ground? And that number was 32 degrees. So this is where you have to really interpret this and draw this well so you can see where the 3-dimensional is. Now, since this is a vertical cliff, we can assume that this is a 90-degree angle. So I kind of have to draw this so it looks like it's in the air. So we have 2 angles on this triangle. That means we could get the third if we wanted to, but we don't need to. And then we're not quite done yet. She moves to point B and measures angle CBA is 62 degrees. So CBA is from here to here to here. So CBA is 62, so that's there. And of course, we want to know the height of, so again, that side of that vertical triangle is what we're trying to get. Okay, so we put all the information in here. Let's go through the questions here. There's a 3-parter. So question A says, are any of the triangles in this problem right triangles? This one is not, although we should probably measure that third angle now that we can. But you can see that this would have to add up to 90, and it's way over. So only ACD is 90 degrees. I guess I should say is a right triangle. That's more of an angle statement. Okay, part B, which length would you determine first? Since select the appropriate trig tool and determine this length. Determine the length to the nearest meter. So again, we can go through the process we did on the first question. If I'm trying to find h, well, it'd be great if I could just look at that vertical triangle. But unfortunately, well, again, just like last time, I know these two angles, 90, 32. I could get the third angle if I wanted to, but there's no side information at all. So we can't work with that. And again, like my suggestion on the last question, it's going to involve that common side length. So we want to find the length of AC first. So which length will you determine first? Well, that would be AC. So find AC length, and we should be specific. We're not going to find it from ACD triangle. We're going to find it from the ABC triangle. Okay. Now, that third angle, we talked about that earlier, this angle ACB, well, that's going to be 180 minus the other two angles, and that works out to 67 degrees. So I can go back in my picture, update my diagram. So now I've got all three angles and one side. We already know, and we just confirmed it, this is not a right triangle. So we cannot use trig ratios. We have to use sine law. So ask yourself, can we use sine law? Sine law, we need an angle and its opposite side pair. And the only side we know is this. And so we know its opposite angle, and we know the other two angles. So yes, we can use sine law. Notice that if we didn't put that angle 67 in, we wouldn't be able to use sine law because we need to have that as part of the solution. So very important that you do that third angle calculation, update your diagram. Okay, so let's use sine law. So I'm trying to find AC. So I'm going to put that at the top of my first ratio, the length of AC, and that's going to be over the sine of the opposite angle, sine 62. Okay, and then the other ratio has to be complete, meaning I have to know both the side and the angle, so it has to be this angle of 67, the side of 150. So remember, the sides are on the top, the angle's on the bottom, and it would be over sine 67. So multiply both sides by sine 62. Again, don't do intermediate calculations with these types of questions. Wait till you get your final calculation and then do it all at once so your rounding is more accurate. So AC, when I round this to the nearest meter, it's 144 meters. Okay, and now I can, I could update that picture, but I think instead I'm just going to redraw the new triangle. So the new triangle, especially since that's a vertical triangle. So if I just do it in 2 dimensions, it's usually easier. So here's my H over here. I'm just going to turn this over on the ground. I've got my A, C is in the corner, and D at the top. So there's my triangle, and I know that this angle of elevation was 32 degrees. And I just got the fact that this side length AC was 144 meters. Okay, so again, that's a right triangle. We talked about that in part A. So can I use trig ratios? Yes, I can. I've got a side and an angle, and that'll be enough. So which trig ratio should I use? Well, the height, or the H, is the opposite based on the reference angle 32, and this is my adjacent side, so I'm going to be using tan. So tan of 32 is equal to opposite, which is H over 144. So H is equal to, multiply both sides by 144, 144 tan 32, and that's equal to, if I round to the nearest meter, that's 90 meters. Okay, and that's what we were looking for. So concluding word statement, therefore the height of the cliff, sorry about that, height of the cliff is 90 meters. Okay, so there's the calculation. Redraw the triangle and then do your 10 ratio. That's going to give you your h, and solve for h, you get 90 meters. Okay, so that's how you do it. I find this type of actual question very fascinating. If you think back to the days when we didn't have all these special electronic tools, that somebody could actually be on one side of a river and be looking at a cliff, so you can't even cross the river, let alone climb that cliff. And through trigonometry, you can just do some measurements from this side of the river and be able to calculate the height of the cliff. So lots of really cool applications with trigonometry tools. For example, the distance of stars is based on trigonometry, at least it used to be. It was a very important part of how we calculate things. Your GPS on your phones and your cars, and that's all based on triangulation, which uses trigonometry, three-dimensional, to figure out where you are on the Earth. Okay, so that's our second question. Let's go to example 3. So example 3, well, they're kind of telling you we're going to use cosine law, so there goes the surprise. Now this one, the drawing's a little more complicated, so let's try to go through. This is a high degree difficulty question. The other two were low to medium difficulty. This one's going to be tougher, and it all comes down to the picture. Okay, and this one, picture would, at least part of the picture would be included, but let's try it out. Okay. Justine is flying in her hot air balloon, so just the fact that she's in the air leads you to believe that this is going to be three-dimensional. She reports that her position over a golf course located halfway between Emerytown and Fosterville at an altitude of 1,500 meters. Fosterville is 16 kilometers east of Danburg, and Emerytown is 16.5 kilometers from Danburg in the direction 42 degrees south of east. What is the angle of elevation of Justine's balloon as seen from Danburg to the nearest degree? Okay, lots of stuff there, right? So let's start with the position of things on Earth. So we're going to be building points and triangles on the ground. So we've got three towns, Danburg, Emerytown, and Fosterville. So what does it say about those? Fosterville is 16 kilometers east of Danburg. So let's start with that. So we've got Danburg here, and we've got Fosterville here. So of course we're going to call those D and F. It's funny how all these town names always appear like 3 letters in a row in the alphabet. Probably just a coincidence, or not. So the distance from Danburg to Fosterville, if I draw my line there, that's 16.0. I'll put the 0.0 just because they told me that. And this is east. Okay, and then Emerytown is 16 kilometers from Danville in a direction of 42 degrees south of east. Okay, so these 2 points, even though it might not look the way I drew it, this is like directly east-west of each other. Okay, so if I'm going to draw Emeryville, it's going to be at an angle of 42 degrees from this angle, because this is like east-west, and Emerytown is direction of 42 degrees south of east. So south of east means 42 degrees that way. So I'm going to put my E for Emeryville here, draw my line. and then this angle here is 42 degrees. Okay, and I guess I can complete my triangle between the three towns. Oh, I forgot to put the distance, is 16.5 kilometers from Danburg to Emeryville. Okay, so let's see what we've used and what we haven't. So we basically put all the information on the ground. Now, Justine's in her hot air balloon. She reports that her position is over a golf course located halfway between Emerytown and Fosterville. So halfway between there and there, I'm going to put a point on the ground where she's going to be directly above in her hot air balloon. And halfway, I'm going to put that information using these little hash marks that show that those two distances are the same. I'm going to call this G for golf course. Okay. I guess the only thing I don't have now is the hot air balloon. So everything I've drawn so far is on 2 dimensions, the ground. And now I'm going to put the hot air balloon is here, directly above the golf course. And I'll give that the letter, oh, I don't know, let's call it I. So now you could see another triangle forming here. We want the angle of elevation from Danburg to where Justine's balloon is. So it's, excuse the not totally straight line there. So I need to draw a line along the ground from the golf course position to Danburg also. Okay, so you can see that that big triangle there, that's all on the ground, and then this triangle here is a vertical triangle above the ground. So it's a little hard to see this here, but I'm looking for this angle of elevation. So this theta is what I'm looking for. Looks like a paper airplane, kind of upside down. So this is going to be involving multiple steps. This is, like I said, a very complicated question. Now, ultimately, I want to get, IG. That's what I'm sorry. Well, I need to get IG so that I can get that angle of elevation. But how do I get IG? Well, I need to get it using the bottom triangle. So the first thing I'm going to do is look at the big triangle DEF, and I want to see what I've got with that side. I've actually got 2 sides and the enclosed angle of 42. So that, there's our hint, cosine law. So I'm going to use cosine law to find EF in triangle DEF. Okay, so if I adapt this to cosine law, this is going to be, the 42 is the angle I'm using. So the opposite side, EF, is what I'm going to be solving for. So EF squared, and I'm not going to use the magnitude or the vertical lines this time. I don't want it to be too cluttered. So that's going to be equal to the sum of the squares of these 2 sides. So 16.0 squared plus 16.5 squared minus 2 times 16 times 16.5 times cosine of the angle 42. Okay, now I'll just, I'll do this in one calculation. That works out to 135.87. When I take the square root, I get EF, and I guess I'll put the magnitude now, is 11.7 kilometers. So that tells me back here that's 11.7. Okay, and because the golf course is halfway, then I can just calculate each of these 2 sides as being half of 11.7. So golf course is 11.7 divided by 2, which is 5.85 kilometers from Emery Town. All right, so I've got, I've got each of these as 5.85 kilometers now. Now, the other thing I'd like to get, because ultimately I'm probably going to be working with one of these two half triangles that are on the ground. I need to get one of these angles, and I'm going to focus in on this side here. I'm going to get angle E. So find angle E in triangle DEF. Probably could have gone the other way too, but this works, so let's do it. So for this, I'm going to have to use sine law, because obviously that's not a right triangle. At least we don't know that it is, so sine law has to be the way we go. So if I want that angle E, it's going to start off with sine E is equal to, sine E over the opposite side, which is 16.0, is equal to, and then the side that I actually know, side angle combination, would be the angle of 42 and this length of 11.7. So it'll be sine 42 over 11.7. So sine E, let me just go to the final, basically angle E is equal to the sine inverse of 16.0 sine 42 over 11.7. Do that in one calculation. We get angle E is equal to 66 degrees. Okay, so I can go back to my picture here, put a 66 in there. We could figure out what F is, because we've got that's 42 at D, 66 at E. We could figure out F, but we're not actually going to use it. So let's just stick with what we need. Now we go to the third step. There's actually going to be 4 steps in total, just so you know. The third step will be to get this side here, DG. That'll give us the information we need to work with the vertical triangle. Okay, so find DG in triangle. So this is where we're now picking one of the half triangles on the bottom. So triangle DEG. So we're only working with that part. So DG, you can see that, well, again, we don't have a right triangle. So we're going to have to use cosine law because we've got this angle 66 and these two sides. So cosine law a second time, which is a rarity for any word problem. So DG squared. So that's because I've got that angle 66, I can solve for DG, the opposite side. So DG squared is equal to, so we know the lengths of these other two sides. So it's going to be 16.5 squared plus, this time it's 5.85 squared minus 2 times 16.5 times 5.85 times cosine of our angle, which was 66. Okay, and if I do the whole side in one step, it's equal to 227.95. Take the square root, we get the magnitude of that side. Length of that side is 15.1 kilometers. So I can update my picture now with that. So the distance from Danbury to, Danburg to the golf course, direct line, is 15.1 kilometers along the ground. And finally, we're at the point where we can start working with that vertical triangle. You could redraw this if you wanted to, but there's been a lot of work. I think I can see that triangle pretty well. what I can see is the angle of reference is what we're trying to find. So we have the, hold on, angle D. Oh, yeah, the one thing we didn't put on here was the height of the balloon. It was, so that side there, we actually do know that. So that's 1,500 meters, but remember every other measurement here is kilometers. So let's convert that by dividing by 1,000. So that's 1.5 kilometers. Okay, so that makes sense now. We actually know two of those three sides. We're trying to find that angle. So that's the opposite side, adjacent side. So, okay, so we're going to find angle D in triangle DIG. So, yeah, let's just draw it again, just so you can see what we're working with there. So there's G, there's I. This is 1.5 kilometers. This is what we're trying to find, theta. And the other side we know 15.1 kilometers. Okay, so yeah, that is better. Just draw that. So, actually, you could call it D or theta. Let's call it theta. Angle D is a little bit vague because there's a lot of angles coming out D. So let's just use our theta as our variable. Okay, so tan of theta is equal to opposite over adjacent, 1.5 over 15.1. So angle theta, well, just theta. Theta is equal to tan inverse 1.5 over 15.1, and that's equal to 6 degrees, rounded to the nearest. So we're finally done this question. Therefore, the angle of elevation of the balloon from Danberg is 6 degrees. Okay? Never forget, these word problems have to have a word answer. You can't just leave it hanging by saying theta equals 6 degrees when the question is how high is the balloon? Sorry, what's the angle of elevation of the balloon? Okay, so zoom back out, see this question. So you can see this is a lot of work, this question. 4 steps with a fairly complicated diagram. Strategy to get there was quite something to know what do we need to find next. Sometimes you have to work backwards and say, okay, if my ultimate goal is to get theta, what do I need from this triangle that I don't have? Well, I have to get that common side. So it's basically, how do I get this common side? Well, I can work with this triangle here, so I need to figure out, well, I need this angle and this side length, so it's working towards getting these two pieces, which we did in steps 1 and 2, and then get DG in step 3, and then get the theta in step 4. So there's three good examples of some fairly complex three-dimensional word problems using trig. So got some homework questions there for you to try out. Just be patient. They don't, you have to think your way through these. Make sure you draw a nice diagram if one is not provided. And then just remember that common side of the two triangles is the key. You usually have to figure that out before you can get what you're ultimately trying to find. Okay, so that's it for today. Thanks for joining me, and we'll see you on the next lesson.